Alrighty, let's talk about fitting, modifying, or setting the coordinate systems. Once you have an understanding of what coordinate systems are, the mistakes that can occur, what the most common ones are, how to change them from one coordinate system to another, how we develop a GCS, what a datum is, and all those other things, you'll eventually get to the point where you'll say, that's great. How can I make my coordinate system as accurate as possible at this location? Or, what do I do when the toe of Louisiana sticks outside my UTM zone? How can I fix that? Because I want the level of accuracy for eastern Louisiana to be the same as what it is for the rest of the state, or at least comparable. In other words, I need it all to be in the same zone. Well, first thing we're going to talk about is setting the coordinate system for your data frame. And so your data frame is, when you look in the table of contents on the left side of your ArcMap window, the very top of the list of your data is the frame. And in that data frame, you add your various sets of geospatial data. The data frame will have a coordinate system. It is the default to use the coordinate system of the first piece of data you add into the frame becomes the default for the data frame. But if you know you want it to be in something else, you can set that. You can change its properties and make it whatever you want. So in general, if you want to make your map really accurate for somewhere, set the coordinate system up for your data frame to reflect that desired accuracy. Add in your data and then project them into the same coordinate system, the modified coordinate system of your data frame. Pretty straightforward, at least it sounds that way. And we'll walk through that whole process. But basically, under the data frame properties, under coordinate systems, there's various folders. You can have favorites that you list, but there's also ones for just geographic or projected coordinate systems. And within those lists, there are all kinds of opportunities for you to select one, and it will then populate the window below with the actual spatial reference information for that coordinate system, so that everything that you just add in will then be displayed in that projection. How do you find them? Well, if you're looking for projected coordinate systems in the US, they're going to be under Continental. You can then go into those properties of that projected coordinate system, and you'll see some values there for false, easting, false, northing, the central meridian, and your standard parallels, and you can change those and move it around. If the coordinate system you choose does not have the right properties, you change them. And here we have a central meridian to change the center point of the map. No problem. You can also basically create a brand new coordinate system, a modification of what you have here by selecting what you want and then changing these values. But generally the way we would do that is we would start and take note, write down what these values are, look at the map, figure out what we need them to be, and then make those changes. So what are the different ways to set a spatial reference? You can go into the various layers, find the one you're looking for, and select it. You can click on that little globe icon and find the new one, or you can import one that exists from another data set. You can also copy and modify data, lots of different ways. What if the zone and the location don't line up, like I said earlier? There's different solutions. Here we're going to cover a couple examples. Oregon covers 2 UTM zones and 2 state plane zones, so there's not an obvious solution that it should be in state plane or it should be in UTM, so that means we have to change one or the other to modify it to be the best choice we have, or a better choice. So how do we do that? Well, could be there's already one out there like Lambert, Oregon statewide Lambert, that's been set up to be that thing we're looking for, or we might end up making our own. If we look at Louisiana, a little bit of the state is outside of that UTM zone. The center of the state of Louisiana is at about negative 91.5 degrees, whereas the central meridian of that zone is at negative 93. If we adjust the negative 93 to negative 91.5, it will center the UTM zone over Louisiana. And so all that space to the left of Louisiana, that is what we commonly refer to as Texas, that blue line, if you will, would move to the right. Both of those blue lines would move to the right, so that all of Louisiana would be inside the zone, and less of Texas would be inside the zone. Effectively, just by realigning that center value, it effectively just creates a UTM zone that is more Louisiana friendly. Kansas got a north and a south state plane. It's all or nothing kind of a deal with this. What are we going to do? We can't look at UTM zones or anything like that. If we're going to modify the state plane, how do we do that? Well, what if we found the center of each of those two state plane zones and just modified one of the two, because conic projection has two standard parallels, and we set it up so one of the standard parallels ran through the top part of the state and one ran through the bottom part of the state, effectively making a single state plane zone that has been expanded so that it would then more correctly represent the entire state of Kansas. Only requires changing a couple numbers. The hardest part's figuring out what those numbers need to be. How would you do that? You change the display units on your map to angular degrees, to GCS values, and then you put your pointer on the map and see what the numbers are at the bottom of the screen, and you make a note of what it should be for where you want these lines to go, and then simply do it. Maybe a better example is sometimes there is no data there. There is no UTM or state plane data that's close to what you want. In this example, we're looking at the nation of Turkey, and we don't have a defined projection specific for Turkey. So maybe we'll just create one. We'll use the basis of Lambert conformal conic, and we'll pick a central meridian, 35 degrees, that runs through the middle of Turkey. We'll divide the country up from north to south into three parts, and that'll be at 39.5 and 37.5. That's going to be our standard parallels, if you will. And so we'll modify the Lambert conformal conic so that we have those as the standard parallels. And all of a sudden now we have a what I would call a hyperfit Lambert conformal conic projection that is centered over the nation of Turkey, such that that projection would give us a really accurate display for Turkey. In this example, we created this new projection. We called it the Turkey Lambert conformal conic, and there's what you have. Now, this is a good time to bring up something. Sometimes we get too wrapped up into the distortions, and we start thinking, oh man, but a conformal conic, it only preserves for this and not for that, and even though I'm in here in the middle and it's right where it needs to be, everything's going to be off. Distortions occur primarily outside of the area of focus. If you center a projection, a conformal conic, a UTM, a whatever, over an area like this, design it like this, line it up like this, if you will, there is minimal distortion of any kind within that map. As you expand out to the rest of the Mediterranean, Asia Minor, Eastern Europe, yes, those distortions that we talk about associated with conformal projections would become more pronounced. But within Turkey, it would be very minimal. These solutions give you somewhat better accuracy for your maps, but there are some considerations. Make sure that you convert all your data to your chosen coordinate system. So once you create a new coordinate system for your data frame, you will then need to project all of your data into that new coordinate system. Be aware GPS units cannot directly collect data in one of your custom coordinate systems. And when you create data using a non-standard projection, be careful that you tell in the metadata exactly what you did if you're going to let this data be used by other people. The last thing you want is for them to think this is ordinary Lambert conformal conic when you've significantly modified that.